Hello, and welcome to the 6th presentation of Avalanche Canada's webinar series. First, we'd like to thank our sponsors. We're very thankful for our sponsors in their financial support to us during this challenging economic climate and working with us to reach new backcountry users this winter. You can see the Meteorological Services of Canada up there. They're one of our key partners and going to be participating in tonight's webinar. We have our program partners, premier sponsors, and our many contributors. Just a few housekeeping notes. Everybody is muted automatically in the GoToWebinar software. There will be an opportunity to ask questions when that time comes. To do so, you'll click on the raise hand icon in the GoTo dashboard, and I'll unmute you so that you can ask your question. And another way will be to type your question into the question chat box, also in the GoTo dashboard. Tonight's presentation is all about getting the most out of the mountain weather forecast. The mountain weather forecast is a powerful tool and can be used by both seasoned weather watchers and those who are new to weather forecasts and data. Lisa Erven, an operation meteorologist with the Meteorological Services of Canada and a contributor to this excellent resource, will start our evening off sharing tips on how to best utilize the various aspects of the mountain weather forecast. Our second presenter, James Floyer, is a senior avalanche forecaster at Avalanche Canada. James will present on how best to synthesize the information found in the mountain weather forecast, combined with the avalanche forecast to help predict avalanche danger. The two forecasts combined are an essential combination in your pre-trip planning. There will be time for Q&A at the end of the program. You can see Lisa there has joined us now, and I'm going to pass it along to her for her presentation.
Great, thank you, Colin.
Thanks, Lisa. It's all yours.
Okay, good evening, everyone. Wow, thank you so much for tuning in tonight. We're here to talk about getting the most out of the Avalanche Canada's mountain weather forecast. And as Colin pointed out, tonight's presentation is a joint effort. I'm joined here by James Floyer, who is an avalanche forecaster with Avalanche Canada. And then there's myself. My name is Lisa Erven, and I am a professional meteorologist. I've been doing weather forecasting for about 10 years with Environment and Climate Change Canada, and mainly forecasting for this beautiful province of BC. Now, when I'm not at my desk, I love being in the mountains. I love hiking, ski touring, climbing, mountaineering, you name it, I just love being out there. But what I don't love is getting snowed on when I'm trying to rock climb and being rained on while I'm out there ski touring. And I'm sure many of you feel the exact same way. And that's why you're here. You want to learn more about the weather and some tools, some really useful tools to help you get out there and get after it. Now, whether you're planning a day out in the mountains or just trying to make it through a presentation on a Thursday evening, it's always a good idea to know where you're going. So here's our plan for tonight. We'll start off with a bit of history on the mountain weather forecast, how it's created, what kind of information is available on it, and how you can use it to plan your outdoor adventures. I'll go over some common wintertime weather patterns to watch out for throughout the season, and provide a quick rundown of some useful weather tools. And then I'm going to pass the show over to James, who will discuss how the weather affects avalanche hazard and where the weather forecast fits into your daily process. So here we go, just a bit of history. So at Environment and Climate Change Canada, we have been providing mountain weather guidance dating back to the 1970s. It's gone through several iterations over the decades. And in the early 2010s, a meteorologist by the name of David Jones revamped it entirely and worked alongside Avalanche Canada to bring it into its current blog style format. So the text, the animations, all the graphics that you see are created by meteorologists at Environment Canada, and then that information gets posted to Avalanche Canada's website. We also work alongside avalanche forecasters daily to help sort out the finer details of storm systems so that they have all the information they need in order to then go and create those avalanche bulletins. Okay, so that's just a bit of history to get us started. First off, let's just look at how a weather forecast is created. So there's 4 key components. The first one being real data. So as a meteorologist, when I sit down at the desk first thing in the morning, the first thing I want to do is look at real data. So I'm pulling up satellite images, radar, and also looking at data from weather stations. On the satellite images, I'm going to get a feel for how water vapor and cloud masses are moving or circulating in the atmosphere. And right off the bat, that's going to tell me where my high pressure systems are and where my low pressure systems are, and you know, how that weather is going to play out over the province. I'm then going to look at some radar data, and radar is going to show me where it's currently precipitating and give me a good idea of where it's going to be precipitating in the near future. But then, yeah, I really want to know, like, what does this all mean for someone standing on a slope? So that's where I go in and I look at data from weather stations. So that will tell me, you know, things about the wind, what speed and direction is it flowing in. It'll tell me, the data from these weather stations will tell me what temperature is occurring in that area, and then how much precipitation has fallen in any given hour. Once I know what weather features are influencing the province, I next want to start thinking about, okay, well, how are these features going to evolve over the next 6, 12, 24, 48 hours, whatever the time frame may be. And for that, I'm going to start incorporating weather model guidance. So here in Canada, we have the GEM model, which is available at a coarse, a medium, and a fine scale resolution. And then several other countries have their own models, and their output can be accessed through a number of websites. You might already be familiar with the European ECMWF, and then there's, of course, the popular American GFS model. And yeah, this stuff can be displayed on websites like windy.com and Spot Weather. Now, here's the secret. No one weather model gets it right all the time. So here in Canada, you know, when I'm sitting down at the desk and I'm trying to figure out, okay, well, which model do I want to go with? I typically start by looking at the Canadian model. You know, it's the model that we can request products for. We've got the most access to the most different types of products. So it's a really good place for us to start. And the first thing I'm going to do is compare how the Canadian model is handling the current situation. So I'm just going to look at the model output and compare that to satellite images. You know, is this model even doing a good job of describing what's currently happening, let alone what's going to happen in the future? From then on, I'm going to start looking at some of the other foreign models and make some comparisons. You know, is the Canadian model moving a low pressure system across the province faster or slower than some of the other models? What does that mean for precipitation patterns? And then, yeah, I've got to start making some decisions. Okay, well, what model, you know, is handling things the best and is likely to give me the best solution? And so how do I make that decision? Well, that starts to incorporate this third component, the theory. You know, so we go through a lot of training to become a meteorologist. There's also on-the-job training, and then the experience that you get year after year of forecasting and seeing firsthand how these systems evolve. So that all of that experience is going to help me to make those decisions on which model I think is handling a particular situation the best. And you know, I still might have to tweak that model a little bit as well. Now, the last component is terrain. So it's especially important when you're forecasting for a province like British Columbia. We've got all these beautiful mountains, but they definitely change the way weather systems evolve as they pass over the province. So you might be surprised to hear that I actually spend a lot of my time looking at terrain maps. And in particular, I'm looking at the orientation of mountain ranges and then the valleys within those ranges. And I'm comparing that orientation to how a weather system is moving across that range. You know, is it moving parallel to that range, or moving across it at some angle, because that's going to have a huge impact on just how much precipitation falls in any given area. So, you know, if I'm a forecaster, you know, trying to write the forecast for, say, Fernie, for instance, and I'm looking out for their big Fernie factor snowfalls, well, I'm going to be watching for weather systems approaching from the southwest. That's the most favorable direction to give those big Fernie snowfalls. Whereas if I'm up here in Rogers Pass, you know, I'm looking for systems that are approaching more from a west direction or from sort of a west-southwest. And then if I'm forecasting along the coast, you know, up through Shames or Bella Coola or Howe Sound, well, I'm really looking for storms that line up with those coastal fjords. And I just want the moisture to be driven straight up those valleys in order to get sort of maximum precipitation out of these systems. So after combining all of these 4 components, I'm now ready to sit down and write the mountain weather forecast. So before I dive into the product and go through each one of the tabs, I first have a question for you. So I'm going to get Colin to give me a hand here, and I'm going to get him to start the poll.
Coming right up.
Awesome, thank you. Yeah, so you should see something pop up on your screen, and the question is simply, do you read the mountain weather forecast already? And if so, how often? So I'll give everyone, you know, 30 to 60 seconds to submit their answer. Definitely don't be shy. If you've never heard of this product, that's totally okay. There's going to be tons of information in tonight's talk for you.
And it's anonymous, so don't be embarrassed, folks.
Yeah. But yeah, also if you're a frequent reader, that's awesome. Like, I can't wait to see what these results show. You know, I'm going to have some more technical tidbits in for users that use this product all the time. So yeah, there should be someone in this talk for everyone. Okay, so results are in. Let's see. Okay, so great, a really good spread here. So we've got, you know, 16% of you that's never heard of this product. Okay, great. Well, you're going to learn a lot tonight. Yeah, 22 have read it a few times per season. Another quarter of you have end up reading it a few times per week. And then, yeah, a whopping 30% read it anytime that you're heading out into the back country. And then, yeah, so we've got some users that read it every day. Oh, this is so awesome! I'm so stoked to hear that this product is reaching the masses. Okay, awesome. Thanks so much for that, Colin. Okay. So for any of you out there who have never heard of this product before, you can go to, I put the website up here, it's avalanche.ca/weather. And when you click on that link, or sorry, when you put that link into your web browser, you're going to come up to a page that looks very similar to this. It'll say mountain weather forecast across the top. You'll see the date that this forecast was issued, also the time. So this blog goes out every day at 4 a.m. Pacific time. You'll also see who it's created by. And then there'll be some sort of catchy title that will hopefully tease you into wanting to read more. Now, when you first go to the forecast, it will default to the synopsis, but there's all these other tabs, and we're going to go through each one of those. So first off, with the synopsis, what kind of information can you expect to find here? Well, when I'm writing this, for instance, I'm going to be discussing the big picture. What are the major weather features moving across the province? Is it is it a vigorous low pressure system? Is it this giant ridge of high pressure? You know, a really strong cold front? That's what I'm going to be describing in this section. I might also talk about how unusual the weather is, if it is. For instance, this past week, if any of you got out into the Alpine in the interior, you know, we saw some really abnormally warm temperatures, you know, 5 to 10 degrees in the Alpine. That's super unusual for this time of year. yeah, that would be something that I would discuss here. I might also just talk about flow direction. So, you know, is a weather system coming in from the southwest, from the north, and how that might influence which one of Avalanche Canada's forecast regions gets hit hardest with precipitation. I might also just talk about the pattern. You know, are we in this persistent pattern where we're just getting storm after storm after storm, and you know, it's just not much is changing, you know, strong winds, lots of precip, just day in, day out. Or it could just be, you know, a giant ridge where we're consistently seeing clear skies and light winds. Or we might be into a time frame where we're shifting from one of those, maybe shifting from a stormy pattern into a rigid high pressure or vice versa. So I might talk about that here. Now, as you scroll down the page, you will come to a 500 millibar animation. And this is direct model output. So a forecaster hasn't touched this image. It's just straight model output from our Canadian global model. And I'm going to blow it up on the screen so that we can talk about it for a little bit. So this is the 500 millibar chart. So this is kind of like your mid-atmosphere level. And the reason why we show it is you can get a lot of really, really key information from this graphic. The winds at this elevation tend to help steer weather systems into the province or away from the province. And yeah, we can get an idea of what's happening wind-wise by looking at some of the features on this map. So I'll first start talking about the geopotential height lines, which are these black lines you see on the screen. And yeah, this can actually tell us what's happening with the winds at this level. So I actually like to think of these lines as the lines on the roadway, you know, when you're driving down the highway and you've got your traffic lines. And so if I'm in my car, I am driving in between the lines, hopefully. And yeah, wind at this level tends to flow parallel to these geopotential height lines. So what that means is if I take my finger or my mouse in this case and start at generally the left side of the image and work my way over to the right side, I am actually tracing the way the winds are moving, but just by following one of these lines. So yeah, the lines themselves tell us what direction the wind is moving, and then how closely packed these lines are to each other gives us some indication of wind speed. So here over North Vancouver Island and the Bella Coola area, you can see that there's really tightly packed contour lines. And so I would expect to see some really, really strong southwesterly winds through this area. Whereas if I look down here towards Oregon, the lines are much further spaced apart. You know, you're still getting southwesterly winds, but they're going to be blowing at a much lesser speed. So yeah, so that's just one of the first things off the bat that you can get from looking at this animation. Some of the other things that are shown on this chart, you've got 12-hour precipitation amounts. So that is precipitation that has fallen over the last 12 hours. And so that's in the colored shading, and you've got the legend here on the top left. Then you've also got some cloud cover in the grayscale. And then you've also got these thickness lines, these dashed thickness lines. And those thickness lines give us some indication of, you know, what kind of air mass we're dealing with, what kind of temperatures or freezing levels we might expect, depending on their value. So overall, this synopsis tab is really about just telling the weather story, just telling that big picture weather story for the province. If we move into the next two tabs, so day 1 and day 2, they share the same format. So when you click on, say, for instance, the day 1 tab, what you'll first see is a graphic, and I've blown it up here in the bottom right. And that is valid for 4 a.m. in the morning. And then beneath it, you'll have a block of text, which is a forecast for 4 a.m. And then we'll go about describing the evolution of weather systems throughout the day. And then as you scroll further down the page, you'll run into a second image that is the 4 p.m. graphic, and then a second block of text for that 4 p.m. forecast. And then we might talk about how the weather is going to evolve during the evening hours or overnight. And something I want to mention about this graphic in particular is that it's actually made by a meteorologist. So we go in and we label, we add in the fronts, we add in the labels for the low and the high pressure systems, and then we provide some annotations. So this is actually created by a meteorologist. We use a computer program for it. Okay, so what are we going to get into? What kind of information can you expect to find on the day 1 and day 2 tabs? Well, this is where we get into the details. What's happening in the various Avalanche Canada forecast zones? So we're going to talk about surface features on this graphic, and then how those surface features influence precipitation patterns, wind patterns, the freezing level, and the cloud cover. So yeah, so these 2 tabs, you're going to get, you're going to get into the details. Now, if you have been a longtime reader, and yeah, our poll has shown that there's quite a few of you here that are, you will have noticed that over the last couple of years, we've expanded this product. So we used to just have text that covered the province of BC. But yeah, over the last about 2 years now, we've added sections for White Pass, which is up in the Yukon. It's just south of Whitehorse. And then we've also added a section on for the Alberta Rockies. So pretty cool. There's just tons of weather information depending on where you plan to be recreating. Okay, moving on to the day 3-4 tab. So now we're moving further out into the forecast period. We consider this more into the medium range forecast. And so with that, now we start to talk about things in sort of a medium level of detail. So you'll get information that's more detailed than the synopsis, but a little less detailed than what you see on the day 1 and day 2. And that's just because we've moved further into the forecast period. We have to talk about things a little bit more generally. There's more uncertainty the further out you go. So yeah, so you'll get another animation. This time, again, it's direct model output from our Canadian global model. And this time it's a surface map. So we'll have isobars, which are lines of constant pressure. That will help identify things like low pressure systems and high pressure systems. And then again, you've got your 12-hour precipitation amounts and your cloud cover and your thicknesses. So somewhat similar to the 500 millibar on synopsis, but now we're coming down in the atmosphere. We're looking at the surface of the Earth. Okay, so what kinds of things will we talk about on the day 3-4 tab? Well, we're going to talk about the surface features that you see in the animation. We try to tailor our text so that it explains what's going on. And yeah, we'll cover things like, again, wind patterns, cloud cover, precipitation. If we start talking about freezing levels and temperatures, it tends to be more in, have a bit more of a general tone. So we might use ranges to describe freezing levels, or maybe just qualitative statements. Freezing levels rising rapidly through this weekend, or coming back down to surface, that sort of thing. And then because we've moved out into this part of the forecast period, and there is some inherent model uncertainty, we might actually discuss it here. So again, we're assessing how well the Canadian model is doing compared to the other foreign models. So yeah, if we think that the Canadian model is a bit of an outlier, maybe not depicting what the future state of the atmosphere will be correctly, then yeah, we might mention that here and sort of suggest ways that you can adjust your plans. And then the final tab, this day 5 to 7 tab. This is awesome. This is for all you weekend warriors out there. So just imagine that, yeah, you've just been out for the weekend, you've had a great time, you've come back and you're sitting at your desk on Monday and you're already daydreaming about what you're going to see for next weekend. Well, this is the tab for you. So it provides a discussion on a Friday, Saturday, Sunday, and then into maybe into Monday morning, like that. That's the time period that it's describing. And so in the weather office, we sit down on Monday morning, and this is where we create this content, and then we update Monday's blog about mid-afternoon and add this content in. So depending on you know, how you go about reading this product, lots of you just, you know, it's something that you read first thing in the morning. Well, if it's a Monday, check back in sort of mid to late afternoon and head for the day 5 to 7 tab, because there'll be new information for you. Now, we also post this information on the Tuesday blog, and that's just to give the product, you know, a bit of a longer shelf life. It's the same information, but yeah, it's just to give readers, you know, longer time to actually read through this product. So what are we going to discuss here? Well, we're moving even further into the forecast period, so we have to keep things somewhat general. We're going to talk about those big picture trends. You know, are we getting warmer or colder, wetter or drier? You know, is there some sort of atmospheric river event on the horizon? We might discuss that. We might just discuss, you know, the general flow direction and the implications of that. You know, model uncertainty again, because we're talking about the long range. So yeah, we might actually talk about, you know, are the models agreeing, or are they all saying different things, and what that means for, you know, how to plan for your weekend. And then we also like to throw in these educational tidbits. So this is an example of a blog post that was written last year by one of my coworkers. He did a really great job here. So in this post, and I know the writing's a little bit small, don't worry about that. You know, he's talking about this omega weather blocking pattern. And he's done this really awesome job where he's included some graphics to show you what an omega block actually looks like to a weather forecaster. And then in the text, he's described, okay, well, why is it called an omega block? And, you know, what does it look like? And then in the second paragraph, he dives into the, you know, the so what? Why does this matter? What impact does it have on BC weather? And then, yeah, he included this graphic and a few others in this blog post to really like bring the message home that, you know, this pattern was going to cause, you know, A, B, and C to happen over the next weekend. So yeah, it's a really cool tab to check out. Yeah, Mondays sort of by mid-afternoon, and then all the way through Tuesday. That's when that information is available. Okay, so before I move on to talk about different winter weather patterns, I just want to take a few moments here to summarize a few key points from this product. So, you know, how do you go about using this product when trip planning? So when I'm heading out in the mountains, I like to think about all the tools that I have in my toolkit. And the mountain weather forecast is one of those tools. It's usually one of the first ones I go to because it gives me that big picture, that big picture trend of just what's happening province-wide. And then those day 1 and day 2 tabs, well, they start to drill into some of the details for the Avalanche Canada forecast regions. But then I still need to rely on some of my other tools, like that favorite website of mine that I always go to for my slope-specific forecast. But yeah, what this product is going to do is provide that big picture outlook of, you know, what's happening across the province, so that when you go to look at your, you know, your spot weather or your windy and you're looking at a point forecast, you know where that forecast sits into the bigger picture, into the grand scheme of things. Okay, cool. So I also wanted to spend some time tonight just talking about some common wintertime weather patterns, and there's quite a few. So I've kind of I've chosen you know, my top 3. So there's going to be 3 examples, and they're all set up in the same way. So I've included a satellite image to show you what it actually looks like on satellite. And then I've included the 500 millibar chart that you would find on the synopsis tab of the blog. And then I've also included the day 1 surface graphic, which is, you know, what a meteorologist has actually drawn to depict this weather system or this weather pattern. So the first weather pattern I want to talk about is what's known as zonal flow, also known as westerly flow, also known as an active weather pattern. So what are the characteristics of this? Well, westerly flow means you've got winds moving from the west to the east. And you can see here on the satellite image, you just got this plume of moisture just coming straight off the ocean, and it's pointed right for the province of BC. If you look over here on the 500 millibar chart, look how tightly packed those contour lines are. So really strong winds, just headed straight for the province. And then here on the surface image, you've got the forecaster has made one or drawn in one frontal system right over the province, and then there's the second weather system, waiting in the wings essentially. So the characteristics of a really active weather pattern, well, it's strong westerly flow across the ocean, and that's going to steer multiple weather systems into the province. And so what you end up getting are these short breaks in precipitation, if any. Depends on how fast those systems are moving in on top of each other. And then, of course, you would expect to see some moderate to strong ridgetop winds with this kind of weather pattern. Now, one thing to keep in mind is that, now it doesn't happen all the time, but certainly some of the time, weather models can have a tough time deciding on how fast these weather systems are going to be steered into the province. Sometimes it actually underdoes the strength of the winds, and what that does to the forecast is it changes the timing and also the precipitation amounts in any 12-hour period. So if I'm heading out into the mountains, and I've read the blog and it's talked about just this really active pattern, one storm after the next. Okay, so I've got that sitting in the back of my brain, and then I go to spot weather and I look at what the forecast is saying for whatever mountain I'm wanting to go to. And maybe my forecast says, oh, mainly cloudy today, precipitation not starting till 6 p.m. Great, awesome, I can go do my route. Shouldn't have many problems with low visibility in blowing snow and whatnot. But in the back of my mind, I'm keeping it in my thoughts that with an active pattern, weather systems can definitely move in faster than forecast. So when I'm out there in the mountains, and I start to see the clouds getting darker and lowering, and then it's starting to, there's light flurries and it's getting a little heavier. I'm already thinking in my mind, okay, this weather system is coming in faster than what the models were saying. Maybe it's time to abort or head to a new objective. The next weather pattern I want to talk about is the Arctic outbreak. So again, I've got a visible satellite image here on the left, and then the upper flow pattern, and then over here on the right, the surface pattern. So in this case, the Arctic front has pushed all the way out to the coast of BC and then basically down to the USA border. And as the name suggests, so an Arctic air outbreak, these cold temperatures originate up in the Arctic. So either over Alaska or the Yukon or the Northwest Territories. And then eventually these ridges slump down into BC and into Alberta and the rest of the prairies. And you can see that it can change the surface pressure pattern and make the isobars clump up. And just like the upper level flow, when we get tightly packed isobars like this, so these solid lines, when they're very tightly packed together, that's indicative of windy conditions. So we in the interior, you would expect to see maybe northerly winds, moderate to strong northerly winds. If you're out recreating on the coast, this is where you could get your strong to extreme outflow winds. Shames and Bella Coola definitely get blasted in these kinds of patterns. Same thing with Howe Sound. Over in the Rockies, you might end up with more of a northeasterly or an easterly as those winds get driven through gaps in the mountain range. So characteristics of an Arctic air outbreak, your frigid temperatures, northerly winds, strong to extreme outflow. And then whenever you combine very cold temperatures with really any wind speed, you have to start worrying about wind chill factor. And that's the temperature that you will feel, and it ends up being much colder than just the ambient air temperature, due to just how your body reacts to wind and cold temperatures and the evaporation of moisture away from your skin. You actually end up feeling colder than it really is. So in those conditions, you got to be careful about bundling up appropriately and trying to reduce your exposed skin. The other thing that happens in these Arctic outbreaks is more unusual precipitation patterns. So if you can imagine that, frequently throughout the winter, our storms tend to come off the Pacific, slam into the coast. They drop a lot of precipitation on western-facing slopes of the coast mountains, and then western-facing slopes of, say, the Caribous and the Selkirks and the Monashees. But in an Arctic outbreak, our front is moving down from the north, and what happens is you get precipitation piling up on the east side of the coast mountains, and also on the east side of the Rockies. So this is where the Alberta Rockies tend to get a lot of their precipitation from. Now, what happens if you combine an Arctic air outbreak with an incoming low pressure system? Well, this is like the holy grail of major snowfall events. So yeah, here in this particular case, this is an example from last year. So the Arctic front had pushed all the way down to basically the USA border, and then we had this incoming low pressure system sort of hitting the coast around Oregon, and there was moisture that was being tossed northwards, sort of up and over the warm front. And it's this clashing of the systems and the fronts that leads to heavy snowfall. So yeah, Arctic front combined with the low pressure system, major snowfall event. And then also, we rely on these kinds of combinations of weather to give us low elevation snow along the coast. So on Vancouver Island and the sea to sky and the Northwest coastal, we can really struggle with freezing levels that just always seem way too high, and we've got to ski tour up through rain before we hit the snow. But in these events, freezing levels come right down to or near the ocean level, and we get the nice light fluffy snow and ski touring right from the car. Okay, the last pattern I want to present is basically the exact opposite of an Arctic air outbreak. It's this atmospheric river. So again, I've got a water vapor image up here, and then the upper level flow and the surface chart. So what is an atmospheric river? I'm sure you've heard of it either through the news or through social media, and it's always got this like kind of dreaded tone to it, like, oh God, here comes an atmospheric river. But what actually is it? So it's a plume of subtropical moisture. So this it taps into moisture and warmth in the subtropics. If it's coming from Hawaii, you might hear of it explained as a pineapple express. But yeah, it's essentially this fire hose. You can see it here in the water vapor imagery, this really bright band headed straight for Vancouver Island and southern BC here. So yeah, you tend to get moderate to heavy precipitation. You can see that in both the upper level chart and the surface chart. Look at these numbers. We're getting into the yellows and the oranges. That's 25 to 50 millimeters of precipitation just in a 12-hour period, pretty substantial. You also get mid to very high freezing levels with these events. And you would also expect to see pretty strong southwesterly ridgetop winds, or maybe even southerly ridgetop winds. However, when you're talking about an atmospheric river, location and duration are key. So in the example that I have up here on the screen, this atmospheric river actually really only grazed southern BC. The more devastating freezing levels and that really hot air mass more affected mountains and ski resorts in Oregon and Washington. They were ahead of the cold front in that really mild air mass, and they were getting rain to mountaintop during this event. Whereas here in BC, we're sort of more on the colder side of things. Even the North Shore Mountains didn't do too bad from this event. Freezing levels stayed like, relatively okay, and we ended up with a lot of heavy snow. For the southeastern part of the province, so southern Monachies, Purcell, South Rockies, they did get into the mild air mass. You can see it here out ahead of the cold front. But yeah, freezing levels really only got up to about 1,500 meters or so with this event. So for the most part, we just got a bunch of heavy snow in the Alpine. But if you can imagine this front, instead of draped over the very extreme part of BC, Washington, if you can imagine it lying, and hopefully you can see my mouse moving, if you can imagine it lying across Bella Coola, Prince George into, into Fort St. John, well then that changes everything. All of a sudden, all of southern BC is in that really mild air mass. And that's where we get our devastating precipitation events, especially for the southwestern parts of BC. Freezing levels here can be anywhere from 2,000 to 4,000 meters. In the interior, it could be 1,500 to 3,000 or higher. It totally depends on the event. Also, duration is really key. So if you're reading our blog and we're discussing an atmospheric river, if we're talking about a multi-day event, well, that just gives the process, or gives the weather system more time to bring in that mild air and really heat things up, versus it just being maybe a one day wonder, and then freezing levels don't actually spike up too bad. So yeah, location and duration are really key. I've now got some useful tools and websites. I know I've talked about a lot of stuff, a lot of weather jargon, and tossed around some weather websites. So yeah, I'm going to provide you with a couple of links here. So again, just to reiterate that the mountain weather forecast is found using this link here at the top. Now, in the beginning of my presentation, I talked about how important it is to look at real data. So actually at the side, to the right of the mountain weather forecast is, you can see this heading, current conditions. So there's actually some really awesome links here to look at radar and satellite. And we've got some really great panels that focus on the province or maybe focus on the interior. So yeah, you can go in and select what you want to see. And then also, if you want to start looking at model graphics yourself, well, there are also a bunch of options to click on. Again, right off Avalanche Canada's website, you can view precipitation, temperature, winds, and all sorts of stuff. It's a really great resource. And then for all you weather weenies out there that want to dive deeper into meteorology and learn more about it, I've got some really good educational links here at the bottom. I think these links are going to be posted in the chat box. But if not, feel free to just hold your phone up to the screen and take a photo so you have these links. The first one is right off Avalanche Canada's website. There is a weather-specific glossary. So you can go on there and read about, well, what is a low pressure system? What is a high pressure system? What is a cold front? There's some really great text and graphics and animations to help describe all those different phenomena. This second link is to a meteorological education website. So you can log on here, you can sign up for a free account, and then you have access to just endless modules on various meteorology topics. Everything from weather basics for all you new users out there, to more advanced things, mountain weather, convection, how to interpret satellite imagery. It's such a great program. I've done many of these modules. In fact, we end up using these for some of our training. So they're really, really well put together, really well explained. Highly recommend that website. If you feel like shelling out some money, then the Canadian Avalanche Association also has some weather courses. I've got the link here to the intro to weather course, but there's also an advanced weather course. So yeah, if you want to spend a few days being taught by, usually it's a combination of a meteorologist and an avalanche forecaster, then yeah, for sure, go in and sign up for these. And then lastly, here's a big block of websites, sorry. But the first couple, if you want to get human created forecasts, well, then you can go to Environment and Climate Change Canada's website, that first one at the top. Also, the Weather Network is another great resource. They have their own meteorologists. For more links to real data, I've got the College of DuPage. It's got some fantastic satellite images. The University of Washington has a really great radar product. Moving down the list there, Nav Canada is a mix. You can get weather observations and then also forecast products. And then Drive BC, if you haven't checked that out, I always go to Drive BC to check the webcams, because yeah, you can just load up what's happening at Kootenay Pass. There's a webcam right on the highway at that level, and see whether it's raining or snowing, and then make your decision on whether you're actually going to go out that day. And then the last three links there, I've just included a couple of really common websites that you can go and get that spot forecast for, whichever slope or mountain or drainage you plan to be recreating in for the day. Spot Weather, Windy, or Wind Guru are all perfectly awesome websites to get your forecast from. So with that, I'm gonna now pass the show back over to James.
Hey, Lisa. Just before handing it over to James, there's a couple of really laser pointed questions that I think it would be good to answer. Maybe it might help to show one of your 500 millibar charts. We have both Jessica and Mike curious about not the solid lines that you described, but the dashed lines on the 500 millibar chart. What do those mean?
Awesome, that's a really great question. Okay, so that is, their full name would be the 500 to 1000 millibar thickness lines. It's a bit of a mouthful, I'm sorry. Yeah, it's describing how thick that layer is. So, oh geez, okay. So I have to get into question answering mode. So the 1000 millibar level is very close to the Earth's surface, and then the 500 millibar level is sort of mid-atmosphere. And then based on an air mass's temperature and density, that thickness will go up and down. So warmer, less dense air masses will have larger thicknesses, and then cooler, more dense air masses, so your Arctic air masses, will have smaller values of thickness. So if I look at, say, this chart, and it's a good one. So right in the middle here, this is a 500 millibar chart. So we've got this atmospheric river event happening, and these higher valued thickness lines, and we've color coded them to help with just ease of identification. The orange lines would represent mild air, so mild air mass. If these high values are poking up into BC, then you would expect freezing levels to rise. Versus the blue dash lines, that's kind of more seasonal wintertime freezing levels and temperatures. And then as you get into these pink dash lines, that's more indicative of an Arctic air mass. So you would expect to see really cold temperatures. And then you can also look at how closely these lines are spaced together, and that will help identify the positions of fronts. Because again, it's really it's a useful tool for identifying air masses, and a front is just a boundary between two air masses.
Great, super helpful. One more quick question. You mentioned that the solid lines, they give us a sense of which way the wind is moving. How do you know along that line which direction the wind would be moving? Would it be moving east or west or?
Yeah, great. Another really great question. So in the Northern Hemisphere, our wind pattern generally flows from the west to the east. So in this graphic that I have up here, you would be moving from the left-hand side of the graphic and following the lines over to the right side. I don't think I have an example where the lines actually tilt back on themselves, but if you can imagine this really bolded line here, if you can imagine it tilting backwards, and that happens with certain atmospheric conditions, then yeah, you would expect to get some more easterly component to that wind. Yeah, hopefully that answers things
Yeah,
better.
I think that helps, definitely. The other questions are a little more general, so I think I'll save them for a little bit later when we do our Q&A, and we'll hand it over to James. Thanks so much, Lisa. That was awesome.
Awesome, great.
There you go, James, you're on.
Okay, thanks, Lisa. That was amazing. That was absolutely fantastic. One of the best bits about my job as an avalanche forecaster is getting to talk to Lisa and many of her colleagues about the weather on a daily basis. And we do that to inform the avalanche forecasts. And it's a real highlight of my day working for Avalanche Canada. So, you know, it's absolutely fantastic. And I always find I learned something, including tonight. So I'm going to try and run through a bit of a connection between weather and avalanche hazard and avalanche danger, and then just put some of the resources into context and maybe suggest some ways that you can incorporate a really good meaningful weather analysis into your daily process. And I'm going to try and speed along a little bit. I suspect I'll try and aim to finish right around 8 o'clock here, but it might go, we will keep the webinar going for some questions after that, for those who wish to stay for that. Just before I go too much further into this, I know a few of you before this webinar started saw some pictures on the screen. We didn't realize that we were sharing that, broadcasting it to the world. Colin and I actually went for a ride today in the mountains near Revelstoke, and we went to go check out the Valley Cloud, which is quite spectacular right now. And you go through the Valley Cloud and you break out, and it's absolutely fantastic up there. We went to do some temperature checks and do some rescue practice and things like that. So there's Colin riding up in the mountains around Revelstoke. And so I'm actually submitting this observation here in the Mountain Information Network here. And for people who do go out in the mountains, this is such a great resource, and I really would encourage you to submit that. So I'm going to submit that right now. If this works, hopefully it does, then you can go on to the Avalanche Canada website and look for that. Look for Boulder Mountain near Revelstoke, just kind of north and slightly west of Revelstoke there. So you can go check that on the website right now, see those photos. So if I go back to my presentation here, I'm going to ask, how does the weather affect avalanche danger? And I'm going to consider sort of three cases, if you like. I'm going to consider storms, so stormy weather, and I'm going to consider what happens when we get clear weather periods. And then I'm going to consider what happens when we get periods of warming. And these aren't the only types of weather, of course, but these are significant weather from an avalanche point of view. So stormy weather, in some ways, this is the most obvious type of weather that will lead to avalanche hazard. Because we even have a name for it. We call it direct action avalanches. And these are avalanches that occur just because there's so much new snow that happens under storm conditions. And when you get a lot of new snow, essentially what's happening is you're building up a snowpack very rapidly. You'll get interfaces which can act as weak layers within that storm, or sometimes at the base of the storm snow, between the storm snow, whatever was lying on the snow surface before that. And when we rapidly accumulate the new snow, it doesn't have enough time, that snow doesn't have enough time to strengthen as at the same time there's more mass being added to that. And we get This type of avalanche, it often affects steep terrain. When it's storming really hard, it may not be aspect dependent, may happen on all aspects. Although, of course, if there's wind as well, then that will maybe mean that some aspects will be preferentially loaded compared with others. And there's some rules of thumb here. And as avalanche forecasters, we often fall back on these rules of thumb, and they don't apply in all situations and everywhere, but they're a really good place to start. And we find that we tend to start seeing natural avalanches occur when there's around about 30 centimeters of snow that's fallen within 24 hours. Or if it's snowing hard at, say, a rate of 2 centimeters an hour or greater, then after 10 hours of hard snow, then again, we'll start seeing natural avalanches start to happen. And so, you know, maybe there's a, I don't know, a centimeter of snow on that helmet or something like that. So if you've been in a warming hut for, you know, half an hour or so and you come out and your helmet looks like that, then you know, it's probably snowing fairly hard. So actually, Colin, would you mind, I guess I can play it from my screen here. I'm just going to play a quick video here. And I actually have a little video of a storm slab avalanche. So this was actually triggered deliberately. In fact, that's actually one of our Avalanche Canada field technicians assessing how sensitive that is. And you can see it only requires a little push, lots of new snow, steep little bit of terrain. There's actually a little break below, which it's somewhat wide slope, but not very long, and very easy to trigger. And during the storm, of course. So back here, I think I close up that. Okay, so I think I'm sharing the right thing again. So we're back to our stormy weather again, and wind slab avalanches here as well. And wind is such a big player when it comes to loading snow, blowing it around. It just can't be ignored. And you have to think about where the wind is, where the wind's blowing, where it's blowing from, where it's blowing to. And under windy conditions, it's very easy to see 2 to 3 times the loading rates compared with whether if it's just simply snowing. And the critical wind speeds for getting that enhanced loading rates are around about 25 to 50 kilometers an hour. 25 kilometers an hour kind of feels a little bit fresh. 50 kilometers an hour actually feels fairly strong winds. Certainly, you know, enough to you know, notice maybe be difficult to walk into and that kind of thing. And I've got an image here, a video of some wind loading in action. You can see just how much.
Hey, James, just unmute yourself to speak over the video.
Thanks, Colin. I appreciate that. Yep, I'll just show it one. Okay, moving on.
Sorry, James, we lost you during the video there. We couldn't actually hear what you were saying. I'm sure it was gold though, so maybe you can take another crack at it.
Okay, am I back on? I think I'm back on here.
Yeah, so, you're back on now. The videos do a thing where they auto mute you. Yeah, but you're good now.
Thank you. Sorry, Colin. On the wind video, the point I was making is that you could actually see evidence of a previous wind direction. So there's a previous wind direction that was going from right to left on the screen. And the wind, of course, during the video was going from left to right, and just really increases the amount of snow available for that loading. And it also sets the wind up in these stiff slabs, which are really ripe for creating slab avalanches on steep terrain. So I'd like to talk about clear weather periods and the importance of clear weather periods for avalanches too. And during clear weather periods, we form a couple of crystal types, snow crystal types. And the first one is surface hoar here. And surface hoar are these beautiful feathery crystals. These ones are particularly big here. And what they do is they create a weak interface in the snowpack. And they don't always do that. It depends a little bit on how they're buried. But once they've formed, if they get buried relatively gently by fresh snow, then they create this weakness within the snowpack. And when they're on the surface or only buried a little bit under the surface, they don't act as much of a hazard. In fact, they can actually be really nice riding surfaces for skiing, sledding, whatever you like doing. But once they get buried after, more than around about 30 centimeters, and our critical depth is around 30 to 80 centimeters, where they can be triggered by somebody, you know, they really act as a weakness within the snowpack. So the clear period here is the period of formation, and Lisa spoke to this omega block. So that's one example of a period where you might get an extended period of this clear weather where these surface hoar crystals might have a chance to form on the surface, and then subsequent storms will bury that afterwards. And so there can be quite a prolonged period of time between when these things formed and when they actually create avalanches that can be dangerous. And the critical thing is here we can get a decoupling between the avalanche hazard and storms. And so this kind of avalanche hazard sometimes is not as obvious as the direct action avalanche that we looked at previously. Here's an example. One of the features of surface hoar that's buried, especially when it gets large, is that it can actually create avalanches on relatively low angle terrain. It's such a slidey, slippery surface that even on fairly low angle slopes, you can see slab avalanches like this one here. This is a picture from today. There is Colin riding up the slope, but in the background, more importantly, sorry, Colin, are some valley cloud. And valley cloud does play an important role in surface hoar formation. And often you get enhanced surface hoar formation right around the upper margin of the valley cloud. And that's because in order for surface hoar to form particularly well, you need a good temperature gradient, and that will happen especially at night near the snow surface when you get long wave radiation loss from the snow surface. You need moisture content, and that moisture can come from the cloud. So that combination of a clear view to the sky from just above that cloud layer and the cloud, the presence of the moisture in the cloud creates almost the perfect conditions for surface hoar formation right at the top of that cloud. So the other crystal type I want to talk about quickly are facets, and they're very closely related cousin depth hoar. And these form within the snowpack. So surface hoar is a surface crystal type. Facets and depth hoar form within the snowpack, and they grow when there is a large temperature gradient in the snowpack, and that tends to happen when things get cold. And we tend to get our coldest weather again during clear periods, often during early winter or midwinter periods where we get very cold overnight temperatures. And if the snowpack is relatively thin and it hasn't grown to our levels that we see further on in the season, then we set up these temperature gradients which can promote the growth of this type of crystal. And we see here in this image here, somebody's pointing, Martina is pointing, I think that is at the base of the snowpack where we've got these weak, sugary depth hoar crystals, and you can see one that's blown up a little bit here. And she'd be able to poke her finger into that quite easily. And so there is an example of a weak layer formed by these depth hoar crystals at the base of the snowpack, potentially giving us a weak snowpack in that area. So warming, and warming is most critical when it warms up to close to 0 degrees C. So of course we can go from -30 to -20, but that's not as dramatic as if you go from say -10 to 0 degrees C. And snow tends to change its properties a little bit as it gets close to the melting point, and it will start to creep downhill. And in this case, it's actually formed a giant pinwheel here, which is an indicator that things are warming up. And the other thing that's important from an avalanche point of view is to have something for that warm temperature to sort of act on, if you like. And we find that the first warming period after a storm can often be the most significant period where we see dramatic avalanche activity. And here's an example. This is mostly loose snow avalanches. They're quite large. Some of them run from the top of the ridge all the way down to the bottom. But in actual fact, loose snow avalanches only affect the surface of the snow, and they tend not to be the ones that catch people out. But you do get slab avalanches under warming conditions, such as this one here. Imagine actually the air temperature might be fairly cool here, but the influence of the sun also can have quite a profound effect on the snowpack as well. In a similar way, it actually acts in a similar way that warm temperatures do as well. We often see avalanches like this releasing as slabs when they first see the sun after recent snowfall. So how do we take some of the information that Lisa told us and incorporate that with the information that we know now about how avalanches work a little bit, and incorporate that into a sort of daily process? And our daily process is our recommended plan of action, if you like, for when we go into the backcountry. And it starts here at number 1 on the left-hand side here at the bottom, get the forecast. And we can interpret that get the forecast as get both the avalanche forecast as well as the weather forecast. And for our weather forecast products, what can we turn to? We can turn to the Avalanche Canada Mountain Weather Forecast produced by Environment Canada, Meteorological Services of Canada, and hosted on the Avalanche Canada website. We can get a more detailed local forecast using something like spot weather. We can check the details in the weather tab on the avalanche forecast, and I'll talk more about that just in a second here. And then we can use observation, so we can go to weather stations in the backcountry to actually get a sense of what's actually happening, hopefully close to where we want to go. Then as we move around our daily process, we're gonna, once we've got our best knowledge about both avalanche conditions and weather conditions, that's when we go into planning our trip. And we want to take that information and then figure out a good place to go. And if you take an avalanche skills training course, then one of the things you'll learn to do is use a tool called the evaluator to assess what kind of avalanche terrain might be appropriate. And obviously you also have to decide from a weather point of view where you'd like to go as well. Check your gear, the recommended avalanche essentials that we really recommend you never leave home with if you're going into the backcountry in winter are an avalanche transceiver and a probe and a shovel. And of course, every member of the group should be carrying all of those. So then we get on to this section here, verify conditions. And this one's interesting. It's basically saying that before you commit to your trip, then you want to make sure conditions kind of matched what you expected. And so from your analysis in the morning, from your avalanche forecast and your weather forecast, do the conditions kind of match what you expected? And one way to do that is to use the details tab. So if you go now onto the avalanche forecast, scroll down, click the details tab, scroll down, you get this weather summary. And the reason why it's really worth looking at that is because this is what the avalanche forecaster was thinking when they came up with the avalanche danger rating and the other bits of information in the avalanche forecast. So if in this instance here, up to 5 centimeters of new snow overnight, with another 5 to 10 during the day. That would have been today. This is in the northwest coastal region. If you'd got to the trailhead and already found 15 centimeters of snow at the trailhead from overnight, and it was still snowing, and it looked like there was another, you know, maybe 10, 15, 20 in still to come, that would be a really good cue that maybe it would be prudent to bump up that local avalanche danger a little bit. And if your intended route had taken you into steep, aggressive terrain, maybe it's time to back off a little bit from that. And you can do a similar kind of thing for both snow, if it's snowing unusually hard, harder than anticipated, or if the wind picks up more strongly than had been forecast or you'd anticipated. And the same with a warming trend. You know, if it wasn't really expected to be very sunny, but you break out above the clouds and suddenly you're faced with a scene like this, then again, maybe avoid those steep south-facing sunny slopes. So I very much hope that you found that useful, and I am very happy to stick around for some questions. Our apologies, we've gone a little bit over time here.
I think we're a little over, but we've still got a lot of attendees here, and there's a lot of really great questions that showed up in the chat box. I should remind folks that the raise hand feature is another way to ask a question, and I'm just going to scroll back in time here to some of these early ones that are really great, but then got buried by all the new ones. So let's see here. We had the lines, we had wind direction, and we have one person, Mike is asking how the mountain weather forecast compares with spot weather results when you're comparing those two resources. And I think maybe that's a question for Lisa.
I think Lisa should answer that.
Yeah. Great, I'm happy to. So the mountain weather forecast, as you saw through my presentation, gives you that big overarching picture. You know, what weather systems are moving through the province. You know, where is that low pressure headed? Is it crossing northern BC? Is it going to come down through southern BC? And so that when you go to look at the spot weather forecast, it gives you just some context. So if you're either seeing that the forecast is calling for a lot of precipitation in your intended destination, or maybe not so much, you at least have an idea of the why. You know, you're getting a lot of precipitation because a low pressure system is set to like roll right over top of you. And the other key piece that the mountain weather forecast plays in looking at then something like spot weather, which is just direct model output, is yeah, I like to have an idea of how close I am to that weather system. You know, am I on the edge of it, and spot weather is showing like, oh, only maybe 1 or 2 centimeters today? Because if I'm on the edge, then, you know, that's another thing I've got in the back of my mind, that, well, if the model is off just by a little bit, I could actually be in for a lot more precipitation than what spot weather is showing me. So again, mountain weather forecast is good for that big picture weather outlook, and then spot weather, you're trying to dial it in, but at least you know some context of why that forecast is saying what it's saying.
Yeah, makes a lot of sense. We've got Marty asking a couple of questions about inversions. First of all, how they're predicted, and if there's any way to any data to let you know the elevation ceiling of the cloud, or maybe the cloud deck, what kind of the extent of the valley cloud.
Yeah, so really great question. So part one, how are they predicted? Well, there's a couple of really common processes that create inversions. One of which is, you know, maybe you've got this cold air mass already settled into the province of BC, and now you've got this upper ridge bringing in a mild air mass aloft. So you've got this mild air mass moving in over top of the mountains, and so now that's going to create a temperature inversion where you've got cold temperatures in the valley bottoms and then this warm air aloft. Another way that it forms is if you get a ridge of high pressure that sets up over a part of the province for many days on end. And, you know, we saw this past week where we had this ridge of high pressure that just sat over southern BC for many days on end. And what happens is you get you get subsiding in the atmosphere. So the atmosphere actually just starts to lower, and as it lowers, it compresses and it warms. And so you can just get warming in place just due to a ridge of high pressure sitting over an area for a long period of time. So yeah, in terms of trying to predict that, well, it's about watching for those weather patterns and yeah, trying to forecast that as it comes in. And then we also have guidance from the weather models themselves. So what I've shown you throughout tonight's presentations have been horizontal depictions of weather, but we actually have tools that allow us to look at the atmosphere in the vertical. We call these atmospheric soundings. And so that will give us an idea of how temperature is changing through the atmosphere as you go higher and higher up. And so the models will actually give us, basically an animation of this warm air being created at higher levels. Part two, remind me. It was
so kind of being able to know, or I guess they were asking for data, but maybe just a way of predicting or knowing when you're on one side or the other where the cloud ceiling and the cloud deck might be when you're in that kind of valley cloud scenario.
Okay, yeah, really great question. Maybe can you can I share my screen again, and
I'll switch it back over to you. Yeah.
Are you, oh, did that work?
Yep, we've got you.
You're seeing windy.com?
Yeah.
But not my emails? Okay, so there's a couple ways you can go about this. I will post this University of Wyoming website maybe into the chat box in a few minutes when I'm done answering the question. But this is a website where it provides real data. So as one of our meteorological tools, we can launch weather balloons that carry aloft instrumentation that measures temperature, pressure, wind, and moisture. And so we can then look at this data, and this is just one website that's free that you can view this data. You want to choose what's known as the skew-T diagram, and then yeah, you select one of these sites. I've got Prince George loaded up here. It didn't quite cover the valley cloud that was seen today over Revelstoke, but I'll use this diagram nonetheless to explain it. So basically, you've got a profile here of temperature, which is the rightmost line, and then you've got dew point temperature, which is the leftmost line. And when those lines are really close together, that's when you would expect to find a cloud layer at that elevation, and you can see the elevation marked in both pressure and meters here on the side. The only problem with viewing real data like this is that we have so few radiosonde soundings here in BC. Your closest one would be Vernon, or else you're going up to Prince George. So it might not actually capture what you're looking at. The other tool that you can use would be to try to rely on something like model data. So here on windy, so Revelstoke had some cloud as per James's photos there. So if you click on Revelstoke, you can get a meteogram, and there's a couple of different options. There's the basic, which just shows you temperature, wind direction, cloud cover, that kind of thing. But if you look at this meteogram option, it actually starts to bring in this moisture layer, and you can see that basically, over the next several days, the models are thinking that low-level cloud's going to hang around. I'll just warn you that on weather models, they can have trouble with the boundary layer in terms of predicting that correct height. So then you can use things like webcams that go through the highway passes to see if they're foggy and actually in that cloud layer. And you can also use weather stations and look at the temperature and the dew point temperature and just see how close those values are together. And if you're within about a degree, you're probably in somewhat of a cloud layer or within a half a degree.
Mm-hmm. Ski hill webcams too. I looked at one of those this morning. That gave me a clue.
Yep.
Another question that's kind of related to your radio sound image there, or your sounding image. Somebody asks, what's the significance of 500 millibars? I guess it's more to do with your 500 millibar chart, but you linked up elevation there, which I think is significant. They ask, is there an altitude associated with the 500 millibar pressure?
Oh, yeah, for sure. So you can see here from this chart, I mean, maybe it's showing up pretty small on your screens, but so pressure is here on the very left side, and then you've got elevation in meters. Yeah, it's kind of hidden by some of these lines, but yeah, the 500 millibar level roughly corresponds to about 5,000 meters.
Perfect. Okay, great. That's helpful. Isaac, he's asking, this is a big question. I'm sure we're all curious about the answer to this one. So since it's a La Nina year, what does this actually mean for the long short-term forecast, so weather forecast, and then over to James for, as well as the anticipated health of the snowpack? This is a tough one.
Great question. So La Nina and El Nino, they're two trends that we look at. And yeah, you know, La Nina tends to be correlated to colder temperatures. But, you know, the forecast of La Nina, and I'm sorry, I'm going to kind of put a damper on this, you know, it's more about weighting the odds in favor of having a colder than normal winter, but it doesn't necessarily guarantee it. We do have to watch the weather from week to week and just see how the pattern is progressing. I mean, yeah, we're supposed to be in La Nina, and yet we've had this giant ridge of high pressure that brought really warm alpine temperatures this past week. So yeah, La Nina doesn't necessarily mean we won't have these little warm spells show up. But the general idea is that it weights the favors and odds of having a cooler than normal winter. So lower freezing levels, more snow than rain.
And on the Avalanche side, what do you think, James?
I love that, and I've heard that La Nina is a marketer's dream when it comes for ski hill promotion. But the truth is that it, you know, I'll echo what Lisa said. It's not a good enough predictor to act as a reliable indicator for what may happen to the snowpack. So again, on the scale of avalanche forecasting, which really does change day by day and week by week, then we really have to go with what's you know, on the ground, you know, rather than fall back on a generalization. So you know, I think you know, the truth is in many parts of the province, we actually already have quite a bit of snow, as well as up in Yukon Territory. And typically, the best indicator of whether or not we'll see some kind of lingering instability near the base of the snowpack is whether we have decent snowpack depths in December or not. And in many places, we're actually looking pretty good. And then, of course, once we start getting weak layers laid down, such as the one that's probably forming right now, then we need to worry about those as the season progresses and take them one weak layer at a time. So, yeah, again, sorry to be a bit of a dampener on the La Nina El Nino phenomenon, because it's a fascinating phenomenon, but it's not a great predictor for avalanche danger.
Yeah, that makes sense. I've got a question here. I think I might have lost it though. Just give me one moment. I'll find it again. We had one person asking, it was about, just give me one moment. So he's this person, Brian, he says he loves the product. I think he's talking about the mountain weather forecast here, probably Avalanche Canada as well. And the handles for the various forecasters, that's definitely the mountain weather forecast. If one wants to see the historical weather info in order to rebuild the snowpack over the season, so snowfall, in order to kind of visualize the snowpack, are there any resources out there? Weather stations are only good, or sorry, it says Avi weather stations are only good for 24 hours. I'm not sure what that refers to, but maybe we can move on from there. But it would be nice to be able to see a longer time frame, like 2 to 3 weeks. what resources would you recommend, James, to kind of get an idea of how to build that concept of the snowpack in a given area?
Yeah, no, that is a great question, and is something that professionals do through the course of a season, is keep quite careful records of the snowpack as it progresses through the winter. So the easiest option is to look in the snowpack description in the avalanche forecast for your different regions. That will give you, I guess, a basic synopsis. If you want to delve deeper than that, there's one resource, they're called snow pillow sites. You can get to them by searching on the River Forecast Center through British Columbia. They're a little bit techy, so you do have to have your kind of, nerdy goggles on a little bit and dive down into some data. But that's probably your best historical record of snowfall, and you can even see when those large storms would come based on when you get the dramatic increases in snowfall, or more accurately snow water equivalent, because these snow pillows actually measure the weight of snow in the mountains, and they're dotted around widely around Western Canada. So that would be the resource I would send you to there.
Great. We've got a comment/question from Lorraine, who was fast and furious on the comments earlier in the session. She says, first of all, Lisa, you're awesome, which we all know. She wants to know how you became a weather forecaster.
Oh, yeah. Well, I guess I'm a science nerd at heart, so I love science through school and whatnot, and atmospheric science is a really awesome applied science. You can actually see what the equations mean by looking at the sky. But yeah, I also just really enjoy looking at clouds. So when I was younger, I thought, oh, there must be some job that allows me to look at clouds and get paid, and that's meteorologist.
That's a good answer. I like that.
Actually, and I'll add on to James's answer from the previous question. To help build back the snowpack, or at least from like the weather perspective, if you go to that avalanche.ca/weather, so our mountain weather forecast, where you see the date, there's actually a little arrow, it's a little drop-down menu, and if you click on that, you can actually go backwards in time and see previous weather forecasts. So that will give you some indication of, was it stormy in your area, or were we under a clear period?
Right. Yeah, great.
Yep. Really good
okay,
point.
I think that's all the key questions. There's some other kind of questions about kind of various other websites like mountainforecast.com and Wind Guru and MeteoBlue. So I'm not sure if we want to delve into each of those products, but if I'm not sure. Is that something that you'd want to comment on? Any of those products? Yeah, might be a little bit.
I feel like I provided a few examples of websites you can go to for.
Yeah, really great list there.
Yeah, and my advice would just be to select one of those and use it this winter season and just get a feel for it. Ground truth it with being out in the mountains. And get a feel for, does this actually do a really good job with the forecast, or does it, does the forecast bust more often than not?
A bit less about which forecast or which product is best, but more about which was best for you and which one you want to count on day in, day out.
Yeah, the forecast can be complicated, so just try one product out, get used to it, and do that.
Yeah, that makes a lot of sense. Okay, I think that is a wrap for us. So I want to just say one last thank you to our presenters for joining us, and to all of our attendees who stuck into the end here. Very engaged and great questions. I want to also say that we appreciate your interest in avalanche safety very much. You can support essential programs like these webinars by donating as little as $10 to Avalanche Canada. It means a great deal to us. Click on the link in the question chat box in order to do that. And our next webinar will be on Thursday, December 10th, and this is about choosing terrain for snowmobilers. So pre-registration will be required for that one, as well as all of our other ones. So thanks again, everybody, and we'll see you at the next one. Bye for now.
Thanks, everyone. Bye.
Bye.